Hello everyone! Welcome! Today, we're diving into a super important concept in organic chemistry, the acidic hydrogen. You might hear this term a lot, and understanding it is key to unlocking many organic reactions. So, what exactly makes a hydrogen acidic? Simply put, an acidic hydrogen is a hydrogen atom in a molecule that can be donated as a proton, which is just a positive hydrogen ion, H+. This happens because the hydrogen is attached to a more electronegative atom. Think of atoms like oxygen, nitrogen, or even a specially configured carbon. This electronegative atom pulls the bonding electrons towards itself, making the hydrogen slightly positive and easier to remove. But the real secret to acidity isn't just about how easy it is to pull the hydrogen off. The most important question is, what happens after the hydrogen leaves? This leads us to the golden rule of acidity: the more stable the molecule is after losing the proton, the more acidic that proton was. We call this leftover molecule the conjugate base. So, how do we predict this stability? There are a few key factors to look for. First is electronegativity. When a hydrogen is attached to a very electronegative atom like oxygen in an alcohol, the oxygen is happy to take on the negative charge left behind, which is more stable than if a carbon had to take it. Second is atomic size. As we go down a group in the periodic table, atoms get bigger. A larger atom can spread out the negative charge over a bigger space, which is very stabilizing. A third, and huge, factor in organic chemistry is resonance. If the negative charge on the conjugate base can be shared across multiple atoms, it becomes incredibly stable. Think about a carboxylic acid. When it loses its proton, the negative charge is shared between two oxygen atoms, making it much more acidic than an alcohol. A fourth factor is the inductive effect. Electron-withdrawing groups, like chlorine atoms, near the acidic proton can pull electron density away and help stabilize the resulting negative charge. Finally, we have hybridization. A hydrogen on an sp hybridized carbon, like in an alkyne, is more acidic than one on an sp2 or sp3 carbon because the sp orbital holds the negative charge closer to the nucleus, stabilizing it more effectively. So to recap, an acidic hydrogen is one that can leave as a proton, and its acidity is determined almost entirely by the stability of the conjugate base left behind. Understanding these factors will help you predict which proton will be removed in a reaction, a fundamental skill in organic chemistry. Thank you so much for watching. I hope this explanation helped clear things up. If you found this video useful, please hit the like button, subscribe to the channel for more chemistry tutorials, and ring that notification bell so you don't miss the next one. If you have any questions or topics you'd like me to cover, please drop them in the comments below. Your support means a lot and helps me create more content for you. See you in the next video.